Hi guys, in this video we are going to discuss another question from differential equation, ordinary differential equation. If you haven't watched our previous video, please watch that also. Also here we are going to see how to solve this problem, this solution. So how to find the answer. So we are going to use separable method to solve this question. If you don't know what's meant by the separable method, don't worry, it's very easy. I'm going to explain that very briefly. Also, if you are new to the Expert channel, please don't forget to subscribe it. Also, we have done many videos regarding basic fundamentals of engineering. If you like to watch that, I have given the link in the description, so you can always watch that. Okay, without wasting our time, let's move to the main chapter. So over here you have seen there are mainly two variables, x and y. So what's meant by the separable method is we are going to separate these two variables in two sides. Actually, if we take that x and there are two parts of x here and the y, there is three parts, so we are going to move that y into one side. Let's say we are going to bring that to right side, and after that we need to bring that x into left side. That's we are going to separate these two. But remember, you can put this constant in any sides, that's your wish. So when you are solving, it's going to be your time, whether it can be in the right or left, it's not a problem. So here the part is we need to bring the x into one side and the y, the forms of y, into another side. That's the first step. After that, the second step would be we need to integrate that. So after that we are going to get the solution. Okay, why I'm waiting, let's start the work. So that we are going to do the, actually we are going to start with the first work. So we can directly find there are two y's part over here, y into dy, and there is x part. So how to bring this part over here? Let's bring this 1 plus y² in this side by cross multiplying this. Likewise, we can directly write this 1 plus x² in this side by cross multiplying this. So if I do so, I'm going to get y over 1 plus y² into dy over, in this side, if I bring this part, it's going to be 1 over, there is no part, so let's write it like dx, or I'm going to write it like 1 over dx, sorry, 1 into dx, and I'm going to divide it by 1 over plus x². You don't need to show that x² is not equals to minus 1 and y² is not equals to minus 1, because we actually knew that always for the real numbers it's going to be positive or 0. So that's not a problem over here. So we have now done with the first part, first step. So now we have brought this y into one side and x into next side. So we are going to integrate with respect to y over here. In this side we are going to integrate this part with respect to x. So that's the second step, the final step 2, dy integration of 1 plus x². So the question is, how are we going to integrate this? Actually, in the previous video I have already told that if you see any function of x over here and derivative of this part over here, you can directly integrate that. You can directly use that form and write it like ln f of x. If you see a function of x over here, and if you see that derivative of this function of x in the upper part, you can directly write that it's going to be equals to ln mod of f of x, this part. However, if you see that if you differentiate this, you are going to get, it's going to be 0 and it's going to be 2y, but here only y. So what can we do for that? Actually, we can directly multiply by 2 and divided by 2. So if I do that, I'm going to get this part. This, let's say this is function of x, the derivative of this function of x is 2y, this is f dash x, f prime x. So if you saw in this form, f of x over f dash x or f prime x, differentiation of this part, you can directly write that integration is going to be ln mod of f of x. So here it's going to be 1 plus y². So you can easily derive this. So the next thing is, I'm going to use this part, I'm going to directly differentiate this part. Actually, we knew that if we have integration of 1 over 1 plus x², it's going to be tan inverse x. You don't need to think anything about that. Tan inverse x, it's a direct differentiation, sorry, integration, you can directly use that. So it's going to be tan inverse x, but remember to put that arbitrary constant, which is c, when you are solving this equation. Sometimes they might give some values and you need to substitute those values and find the value of C, but in this question they didn't told about that. Okay, see, it's going to be arbitrary step. Okay, now we have successfully finished this question. Thank you for watching. If you have any doubts, please comment it below, and if you like to watch our next videos, please don't forget to subscribe. Thank you for watching.